So in this proof, we're given that FJ is congruent to GH and angle JFH is congruent to angle GHF. So this angle. And we want to prove that FG is congruent to JH. So we want to prove these two sides are congruent. If you're trying to prove sides are congruent, but you see triangles, what you should think of is I'm going to use CPCTC, corresponding parts of congruent triangles are congruent, to prove these sides. But first, I have to prove that the triangles themselves are congruent. So I'm going to start with the given information, and I'll color code it. So FJ is congruent to GH, and I'm going to put that in black. And angle JFH is congruent to angle GHF, and I put those in red. So now, our goal here is we want to find congruent triangles. And the way to find congruent triangles with this, we already have a side, we have an angle. And look at this side. This side's right in between the two triangles. They share it, which means that we can say that FH is congruent to itself because they both share FH. And we can do that because of the reflexive property. So there we have it. We have a side, angle, and side on both of these triangles. That right there is enough to prove that triangles are congruent. So let's do that step next. So triangle JFH is congruent to triangle GHF by side, angle, side. So we have the side here, we have the side here, and we have the angle in between for both triangles. Now, since we know that these two triangles have to be the same, that means that the corresponding parts, the parts that match up with each other, now also have to be the same. And in our case, FG and GH correspond to each other, so we can just write that they are congruent because of CPCTC. And that's it. So first thing we did, we proved these two triangles congruent to each other. And then once we knew that, we knew the pieces that matched up with each other also had to be congruent by CPCTC.